how are you? I hope you all are fine. So in this video we will discuss about refraction. In previous video we had already discussed about sign convention and magnification. Okay, so in this video we will discuss about refraction. 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 Okay. So first of all, I would like to introduce that what is refraction. When the light rays, when the light rays are incident on a surface and the light ray goes from one medium to another medium. This then this phenomena is called refraction. Okay. Refraction. What is refraction? When the light rays are incident on a surface, then the light rays goes from one medium to another medium. Okay. Then this phenomena is known as refraction. Okay. Let's see here. This is our surface. Suppose that this one is a ray. Okay. This one is our incident ray. Suppose there is no any surface, then the light, this ray moves in the same direction. Okay. But here is a surface. Okay. So this light ray. Okay. And this one is our normal. Okay. This one is our normal. And this medium is our mirror medium. This is our mirror medium. Okay, and this one is denser medium. Denser medium. Okay. there is no surface, then the light goes in this direction. Okay. Here you can see that this one is normal, and if light ray comes from if light rays goes from rarer to denser, then the light ray bends towards normal. Okay. So this light ray bend toward normal. Okay, because it comes from it goes rarer to denser. Okay, it goes from rarer to denser. Okay, this one is angle of incident and this one is angle of refraction. Okay, this one is mu1 and this one is mu2. Here mu1 is less than mu2. Here mu1 is less than mu2. Why? Because mu2 is denser medium and mu1 is rarer medium. Okay, that's why mu2 is greater than mu1. Okay, and this, you know that this line is our incident ray. Incident ray. Okay, this one is our incident ray and this one is our refracted ray. Okay. And this one is our refracted ray. Okay. And this one is normal to the point of incident. Okay, point of incidence. Here this one is our incident ray and this one is our reflected ray. This one is normal to the point of incident. Okay, and here mu1 is less than mu2. Why? Because mu1 is rarer medium and mu2 is denser medium. Okay, and here I and R is our angle of incidence. Angle of incidence. Okay, here I is our angle of incidence and R is angle of refraction. Okay, angle of refraction. Okay, so what is refraction? When the light rays are incident on a surface, then the light rays go from one medium to another medium. Okay, here you can see in this figure that this light ray goes from one medium to another medium. Okay, so then this phenomena is known as what? This phenomena is our refraction. Okay, and here mu1 and mu2 is our refractive index. Okay, so here mu1 and mu2 is our refractive refractive indices. Okay, indices. Okay, This one is a plural form, and from there we can write refractive index. Okay, this one is plural form and this one is singular. Okay, so here mu1 and mu2 is our refractive index. Okay, and here I is our angle of incidence and R is our angle of refraction. Okay, so I hope you understand that what is refraction. Now let's see that what is that laws of. Now let's see laws of refraction. Laws of refraction. Now let's see laws of refraction. Okay. So I'm going to set this. This one is our incident ray. Then there is only surface and the rays go as usual. Okay. This one is our normal. Okay, to the point of incidence. This one is our radar medium. This one is denser medium. Okay. Denser medium. Okay. This one is radar medium and this one is our denser medium. When the light rays goes from radar to denser, then the light ray bends toward normal. Okay, bend towards normal. This one is normal. Bend towards normal. This one is our incident ray. This one is reflected ray. Okay. Refracted ray. Refracted ray. This one is reflective index, that is mu1 and mu2. Okay. And this one is the angle of incidence. And this one is the angle of refraction. Okay. Okay. Now let's see first what it is. Snell's law. Snell's law. Okay. According to Snell's law, there is a formula that sin pi by sin r is equal to mu2 by mu1. Okay. This one is according to Snell's law that sin I by sin r is equal to mu2 by mu1. Okay. Or you can also write like this: sin I by sin r. Sin I by sin r is equal to constant. Okay. This one is our first one. That is sin I by sin r is equal to mu1 by mu2. Okay. Sorry, mu2 by mu1. incident ray, refracted ray, and this one is our normal to the point of incidence, okay, and incident ray, reflected ray, and normal to the point of incidence, normal to the point of incidence, all lie in the same plane. Okay. Incident ray, reflected ray, and normal to the point of incident all lie in the same plane. Okay. This one is our laws of refraction. Okay, that is first one is Snell's law, that is sin I by sin r is equal to mu 2 by mu 1. Okay, and sin I by sin r is equal to constant. And second one is incident ray, reflected ray, and normal to the point of incidence all lie in the same plane. Okay, so I hope you understand that what is refraction and what is the laws of refraction. Okay, now let's see refractive index. Okay, refractive index. There are two types of refractive index. And first one is our absolute refractive index. Second one is relative refractive index. The two type of refractive index. That first one is absolute refractive index, and second one is relative refractive index, or absolute refractive index, or you can also say only refractive index. Okay, refractive index. Okay, so there are two types of refractive index. That first one is absolute refractive index, and second one is relative refractive index. Okay, now let's see the formula of absolute refractive index. We can write mu1, you can only write mu. Okay, or you can also write like this, mu1 to here, or mu1 here, like this. Okay, it means refractive index of one with respect to air, okay, is equal to speed of light in air by speed of light in medium. Okay. Absolute reflective index is present with respect to the air, okay, and except air or medium are relative index, okay. So here mu is equal to speed of light in air by speed of light in medium, okay. So in air, or you can also say vacuum. Okay. Okay. So you can write that mu is equal to V naught by okay. That V naught is our speed of light in air and V is our speed of light in medium, okay. We have to learn this. Here is a point that speed of light in vacuum or air, or you can also say free space, okay. Free space, or you can also say V naught, okay, or V naught is equal to 3 into 10 to the power 8 meter per second, okay. But here is the point that speed of light in vacuum or air, or you can also say free space, or you can also say V naught, okay. V naught is our also speed of light in air, okay. So you can also write V naught, okay, is equal to 3 into 10 to the power 8 meter per second, okay. Now let's see, for example, reflective index in water. Refractive index for water. Refractive index for water, that mu is equal to 4 by 3, okay. Mu is our, mu you can also write like this, here it is mu is utter with respect to here, or you can also write like this, or mu air with respect to water. Okay, or you can also write like this: mu is equal to mu is w. Okay. So this one is the refractive index for water, and now let's see refractive index for glass. Okay. Refractive index for what? Glass. Okay. Mu g is equal to 3/2. Refractive index for glass, that is mu g is equal to 3/2, and reflective index for water, that is mu w is equal to 4/3. Okay, you have to learn this. Then like this, refractive index of glass with respect to air. Okay, you can read like this: reflective index of glass with respect to air is equal to 3/2, and reflective index of water with respect to air is equal to 4/3. Okay, so I hope you understand this. Now let's see one point related to this, that is that absolute relative index, refractive index is unitless. Quantity. Absolute refractive index, or you can also say refractive index only. Okay, refractive index is unitless quantity. Why? Because here you can say that this one is also speed. So unit of speed is our meter per second. Meter per second by meter per second is cancelled. So absolute refractive index is unitless quantity. Okay, so I hope you understand about refractive index. Okay, sorry, refractive index. This one is the speed of light in a vacuum or air, or you can also say V0. Okay, V0 is equal to 3 into 10 to the power 8 meter per second. Okay, and for example, refractive index for water, that is refractive index of water with respect to air is equal to 4/3, or you can also say that refractive index of water. Okay, refractive index of water is 4/3, and refractive index of glass is 3/2. Okay, and refractive index is unitless quantity. Okay, now let's see about relative refractive index. Okay, relative refractive index. Okay, you have to respect to 1 is equal to speed of light in medium. Speed of light in medium by speed of light in medium 2. Okay. Speed of light in medium medium 2. Okay. We can read like this. Relative refractive index of 2 with respect to 1. Okay, that is equal to speed of light in medium first by speed of light in medium second. Okay, or you can also write like this, mu 2 with respect to 1 is equal to v1 by v2. That is v1 is here speed of light in medium first and v2 is here speed of light in medium second. Okay. Now let's solve question related to this. So here is our question. That question says that find relative refractive index. Find relative refractive index of glass with respect to water. Of glass with respect to water. Find relative refractive index of glass with respect to water. Okay, here refractive index of glass is given, that is 3 by 2. It is 3 by 2 and water is given at 4 by 3. Okay. So now let's solve this question. Here we have to find the relative refractive index of glass with respect to water. Okay, so here mu g with respect relative index of refractive index of glass with respect to water. Okay, is equal to VW by mu21 is equal to v1 by v2. v1 is here speed of light in medium first and v2 is speed of light in medium second. Okay, so here we write VW, this one is our medium first, V, that is this one is our medium second. Okay, medium first, medium second. Okay, so or you can also write like this, relative index of water by relative index of glass. Okay, so here is equal to water 4 by 3 and glass is here 3 by 2. Sorry. Here B is reciprocal by 1 by relative index. Okay, B is the reciprocal. V is inversely proportional to 1 mu. Okay, so that's why inversely proportional. So here we write mu G by mu. Okay, now let's solve for the 4 by 3. Sorry, not 4 by 3. Glass, that is 3 by 2 by 4 by 3. Okay, 3 by 2, 4 by 3. Okay, now here this one is 9 by 8. Okay, if you want to get 3 by 2 into 3 by 4, 3 is 9 by 8. Okay, this one is our answer. So I hope you understand this question, that B is inversely proportional to mu. Okay, now let's see some point related to relative refractive index. Okay, that is refractive index refractive index of air. Refractive index of air is equal to 1.0003. Okay. Sorry, this one is a relative index. Sorry, refractive index of air, that is equal to 1.003. Okay, and you can also write mu is equal to 1.0003. Here mu approx value is 1. Okay, and the refractive index of vacuum is also 1. Okay, refractive index of vacuum is 1. Okay, refractive index of vacuum is equal to 1. Mu is equal to 1. Okay, so this one is the refractive index of air is equal to 1.0003 and and that's approx. You can write mu approx 1. Okay, and here the refractive index of vacuum is equal to 1. Okay, so here clearly that the refractive index index of air with respect to clearly the theory will be same as refractive index of vacuum. Okay. Approximately here is clear that the relative index of air will be same as the refractive index of vacuum. Okay, approximately. Okay, let's see one more point. That when light ray goes from denser to rarer, denser medium to rarer medium. When light ray goes from denser to rarer medium, then the light ray bends away from the normal. Okay. Okay, when the light rays goes from the denser medium to rarer medium, then the light rays bend away from the normal. Okay, and if the light rays goes from rarer medium to denser medium, then this point is very important point, that when light ray goes from rarer medium to denser medium, then the light ray bends towards the normal. Towards the normal. When the light rays goes from rarer to denser, then the light bends towards the normal. Okay, when the light rays goes from denser to rarer, then the light ray bends away from the normal. Okay, like here you can see this figure. This one is our light incident ray. If there is no any reflecting surface, then the light go in that direction. Okay. one is our normal to the point of incidence. This one is denser medium. This one is denser medium and this one is rarer. Rarer medium. Okay. And when the light ray goes from denser to rarer, then the light ray bend away to the normal. Okay, this one is our reflected light and this one is our incident ray. Incident ray and this one is reflected ray. Okay, and this one is normal to the point of incident. Normal to the point of incidence. Okay, normal to the point of incidence. This angle is angle of incidence and this angle is our angle of reflection. Okay, angle of incidence is equal to theta 1, this one is theta 2. Okay, so I hope you understand that when the light ray comes from rarer to denser, goes from rarer to denser medium, then the light ray is bent towards the normal. Okay, and when the light ray goes from denser to rarer medium, then the light ray bends away from the normal. Okay, so for law of reflection here, sin I by sin r is equal to mu 2 by mu 1. Okay, mu 2 by mu 1. This one is our mu 1 and this one is mu 2. Here mu 1 is greater. Why? Because mu 1 is a denser medium. Okay, so here we write mu 1 is greater than mu 2. Okay, and here you can see that theta 1 is less than theta 2. Okay, theta 1 is less than theta 2. Okay, angle of incidence is equal to theta 1, angle of reflection is equal to theta 2 here. So sin I is equal to sin theta 1 and here sin r is equal to theta 2 and here mu 2 by mu 1. Okay, from cross multiple, mu 1 sin theta 1 is equal to mu 2 sin theta 2. Okay, where this formula is very easy to learn. Okay, where mu sin theta is constant. Okay, so this formula is easy to learn, that mu 1 sin theta 1 is equal to mu 2 sin theta 2. Okay, and here mu 1 is greater than mu 2 and theta 1 is less than theta 2. It means theta 2 is greater than theta 1. Okay, so I hope you understand also this points in this question also. Now let's see refraction through a rectangular glass slab. Okay. Refraction through a rectangular glass slab. Okay. Refraction through a rectangular glass slab. Okay. Suppose that this one is our rectangular glass slab. Okay. Okay. This one is air. This one is our glass slab. Okay. Glass. Okay. So this one here, this one is our incident ray. Okay. If there is no any slab, then the ray go as like this. Okay. In the direction. Okay. This one is our normal to the point of incidence, and this one is our rarer medium, and this one is denser medium. Okay. So here you can see that light rays goes from rarer to denser. So that's why rarer to denser. So it bends towards the normal. Okay, like this. Towards the normal. Okay. This one is our normal. Okay. This one is angle of incidence. This one is angle of refraction. Okay, and this one is a denser and this one is air. Okay, so here light rays here. This one is our normal. Okay, this one is normal. Then, and you can see that we have already seen that when the light rays goes from denser to rarer, then the light rays bend away from the normal. Okay. Away from the normal, like this. Okay. So this one is, the both lines are parallel to each other. Okay. Here the distance is our x. Okay, so this one is our refraction through a rectangular glass slab. Okay, so I hope you understand this figure very well. So I hope you understand all the things that we learned today. Last one is the refraction through a rectangular glass slab. Okay, so here you can see that this one is light ray, and it goes from rarer to denser medium, so that's why it bends towards the normal. And here light rays, this one is our light ray, it goes denser to rarer medium, so that's why it bends away from the normal. Okay, to the normal. Okay. We solved this question, and we written that when light rays goes from a denser medium to rarer medium, then the light rays bend away from the normal, and when the light rays goes from rarer to denser medium, then the light rays bends towards the normal. Okay, and we also discussed about what is refraction. When the light rays are incident on a surface, then the light goes from one medium to another medium. This phenomena is known as refraction. Okay, I hope you understand this figure also. After that, we see refractive index. Laws of reflection. Snell's law, and this second point is similar to reflection. Okay, that is incident ray, but this one is changed, that this one is reflected index. Okay, but in reflection we read that this one is, here is written that reflection and reflected ray. Okay, so this one is similar as reflection. Okay, so I hope you understand laws of reflection also, and after that we read about refractive index, that there are two types of refractive index. First one is absolute refractive index, and second one is relative refractive index. Okay, and after that we read some important point related to this. So I hope you understand all this all the video. That's all for today. Thank you. Have a nice day.